Hi students, welcome back to ChemOrgChem. So in this JEE Chemistry Insights series, we have been exploring the solution for previous year JEE Chemistry exam papers. If you are new here, don't forget to subscribe and hit the bell icon for notification. Let's see what's today's problem. So this is the problem from JEE Main 2012. So as per this problem, in which of the following pairs of molecules or ions both the species are not likely to exist? So here you see there are four pairs of molecules or ions are given. So let's solve together which one of the species are not likely to exist. For solving this problem, if we know the bond order of all these molecules or ions, we can easily to find out which species are not likely to exist. So let's moving to the solution. So we have already discussed about bond order in our previous videos. If anyone missed that, you can find the link in the description box. So bond order means that the number of bonds formed between the two bonded atoms in a molecule is called the bond order. So in general, bond order can be calculated by using molecular orbital theory. So however, which takes too much time to calculate the bond order of a given molecules. So we have already discussed about the trick to find out the bond order in simple way. So if we memorize these two diagram, which is really simple to calculate the bond order of a given molecule. So for this, we need to calculate the total number of electrons present in a molecule. Well, the first diagram is useful for a given molecule has total number of electrons 0 to 8. For example, in a given molecule has total number of electrons is 4. So the bond order of the particular molecule is 0. So in case of this diagram is useful for a given molecule has total number of electrons 8 to 20. So let's moving to the our question. First, we should calculate the bond order of all the molecules or species. So for example, the first option, so H2 2 plus and He2. So for that, first we should write it down the electronic configuration of hydrogen atom, which is 1s1, and electronic configuration of helium atom, which is 1s2. So first calculate the total number of electrons present in the H2 2 plus. So total number of electrons present in the H2 2 plus. So now you see here two hydrogen atom. So 1 plus 1 here 2. So here two positive charges. That means that we need to minus 2 electrons. So 2 minus 2 equal to 0. So 0 is here in this diagram. So the bond order of H2 2 plus is 0. So next moving on He2. So total number of electrons in He2 here two helium atoms. So one helium atom is 2 electrons. So 2 plus 2 equal to 4 electrons. So 4 is here. The bond order of He2 is 0. So next moving on our second option, which is H2 minus and He2 2 plus. So just calculate the total number of electrons present in the H2 minus. Here two hydrogen atoms. So here 2 and each negative charges get 1 electron. So 2 plus 1 equal to 3. So 3 is here. The bond order of H2 minus is 0.5. So next moving on, He2 2 plus, the total number of electrons in He2 2 plus, here 2 helium atom plus 2 and 2 positive charges. So we need to minus 2 electrons. So 2 plus 2 and minus 2. So total number of electron is 2. So 2 is here. So bond order of He2 2 plus is 1.0. So next moving on, our option C. So here also you just write it down the electronic configuration of hydrogen atom and electronic configuration of helium atom. So here H2 plus, the total number of electrons in H2 plus. So here two hydrogen atoms, so 2. So one positive charges, so we need to minus 1 of electron. So 2 minus 1 equal to 1. So 1 is here. So bond order of H2 plus is 0.5. So next moving on, He2 2 minus. So total number of electrons in He2 2 minus, here 2 helium atom. So 2 plus 2 and 2 minus charges. So which means that we need to add 2 electrons. So total number of electrons in He2 2 minus is 6. So 6 is here. The bond order of He2 2 minus is 1.0. So next moving on our final option, which is H2 minus and He2 minus. So just to calculate the total number of electrons present in the H2 minus, here 2 hydrogen atom, so 2. So 1 negative charges, which means that we need to add 1 of electron. So 2 plus 1 equal to 3. So 3 is here in this diagram. The bond order of H2 minus is 0.5. So next moving on He2 minus, we have already calculated the bond order of He2 minus, which is 1.0. So finally, we found the bond order of all the given species. If bond order is 0, which indicates that that molecule doesn't exist. So let's moving to the our question. So in which of the following pairs of molecules or ions both the species are not likely to exist? So just now we have calculated the bond order of all the given species. So based on that, here you see H22 plus bond order is 0 as well He2 bond order is 0, which means that these two molecules or ions doesn't exist. So based on that, the correct option for this question is answer A. I hope this video helped to understand this question. If you enjoyed this content, just give it a thumbs up and share it with your friends, and don't forget to subscribe ChemOrgChem. And finally, thanks for watching. Bye bye.